Hi guys, apologies for two things in the last video. One is the fact that I don't think I cracked a smile for the entire time. So sorry if that all felt very businesslike and serious. And second, sorry about the weird colors on my face. In case you missed the little note I put in there, I'm facing the sun right now in my new office, and I haven't, I've moved my office space. And I haven't yet put up proper blinds, so I've just got these kind of sheer curtains. I'm trying to arrange it so there's not too much sun in my face for this, but I'm going to have to get that under control. It keeps going behind clouds, so that's why my face is different in different shots. Okay, let's get on with it. We're going to continue to talk about polymorphism, but now we're going to talk about abstract classes. So if you take a look at the screen here, abstract classes are going to be really useful and solve a lot of problems for us. Okay, the basic idea is that there are some superclasses, like geometric object, for example, they're really too generic to instantiate them. Right? So there's no such thing as just an abstract geometric object. You can't point to something and say, this is just a geometric object. It's not a circle, it's not a square, it's not a triangle, it's just a geometric object. So it's too abstract to really think of actually creating something of that type. Circles, the things that subclass off of it, circles and squares and rectangles and triangles, those are sufficiently concrete and well defined that you can draw them. And say things about them. You can say what their perimeter is, what their area is. You can't do that for just a generic geometric object. So it makes sense to make it not allow it to be used to create an object. So that's an abstract class, and in UML diagrams we use italics here for that. If you're using umlaut, you can put a slash on either side of it, like a markdown slash, and it will turn it into italics for you. So in this new diagram, this is just a part of the diagram from before. We have target, circle. They're both concrete classes. They're like regular classes. You can instantiate them. But geometric object is now abstract. So it's very easy to make a class abstract. We'll do it in a second. You put the keyword abstract in the class header. The thing about abstract classes is, and this is where it gets really helpful for us, and it's going to solve some problems for us, is that some of the methods in a class can also be abstract. So notice that geometric object here now contains a draw method. It didn't used to, but it's abstract. It's in italics. Okay, so this thing cannot be instantiated. It's abstract, and it contains an abstract method. And we'll see why that's useful in just a second. I'm going to do these try it nows with you. So if we go to the geometric object class, we can make it abstract for starters, to begin to make it match the drawing, just by putting the word abstract here. Public abstract class geometric object. That doesn't change anything else in the code that we happen to have here, but the one thing that it does change is that we can't do this anymore. Oops. Oh dear. Yeah. We can't do this anymore. And what it says here is that geometric object is abstract and cannot be instantiated. So that's one of the things. Like sometimes you create a superclass just to hold the common code. You don't really want the users to create objects of that superclass. So that's one advantage already. We're controlling the users of our code a little bit and telling them, hey, no, you can't just instantiate a geometric object. You have to use one of the subclasses of it. It's just there for convenience. But the other thing that's cool about it is that geometric object. Oh yeah, sorry, no, I haven't done that part yet. So that's the first try it now, is just making the geometric object class abstract, and the only difference it creates is that we cannot instantiate it anymore. If we go back here, now we want to add, to make this match the drawing, we want to add an abstract method here. So we're going to add an abstract draw method, and similarly to a regular method, you define it the way you normally would, but you add the word abstract to it. And here's the weird thing about abstract methods. Notice how it doesn't have a body. It just ends with a semicolon. So what we're creating now is a method header. So we're creating like the interface, and we're saying you have to fill in the details later. So, oops, not there, here. So if I go over to geometric object here, I'll just add it at the top here because that's the easiest place for it. Public abstract draw void draw what is it? Graphics context GC. and a semicolon. Okay, so this is an abstract method. I can't have abstract methods unless the class is abstract. I can't put a body on an abstract method. That's a syntax error. An abstract method is kind of like a contract. So you are telling the subclasses, you're saying anybody who wants to extend geometric object into a concrete class like circle, you have to instantiate this. You have to create a draw method that matches this. So over in the circle class, if I decide to, or wait, let's do this a different way. Let's create a new Java class for square. Okay, and we will have it extends geometric object. I immediately get an error. It says class square must either be declared abstract, which is one way you can get around not having a draw method, or it must implement the abstract method draw. All right, so I have to now implement this, and I can, as usual with IntelliJ, there's an Alt-Enter. You can say, okay, implement the methods, go for it, and it creates a stub for me here. So it's saying this is what you have to do. You have to create public draw graphics context. I don't know what you want to do, so I'm leaving it blank. It added the override tag for me, which is optional, but now this is a legal class. So there's a contract being enforced by geometric object. You must have this method. And you must have it can't be an abstract method. You have to have a body for it. Why do this? Well, it goes back to the difference between the actual and the declared type. So if we go back to our draw method here, we realize that we can only call methods if we are using. We can only call methods that appear in the declared type. So previously to this, we couldn't do r.draw. That caused an error before, or c.draw, because geometric object did not have a draw method in it, even though rectangle and circle did. But now we can do this because geometric object contains an abstract draw method with the right interface, which means that we know that whatever type of object this is, it has to have that draw method in it. It's defined in the geometric object class. So I no longer have to do any of this malarkey. I can just call c.draw and r.draw. Oops, do that like this, like this. Okay, I'll get rid of this one. Okay, so lo and behold, it all works. So that's one of the biggest benefits of abstract classes, is that you can have like a polymorphic array or a polymorphic method that accepts things of type geometric object. And if geometric object is abstract and contains abstract methods, you know that the subclasses, whatever they are, will have overridden that method and will have that method available. So I can call c.draw because it appears as an abstract method in geometric object, meaning that it has to be implemented in the subclasses. And it makes sense, by the way, for this method to be abstract, because, I mean, this is one of the things about geometric objects. Unless you know what shape the geometric object is, you can't draw it. You can't just draw a generic geometric object. It needs to have more information than that. So we can't actually instantiate this at this level. This is kind of reinforcing the fact that this is really an abstract class. Okay, what else? Yeah, so we've done the other try it nows, I think. Go to the draw.java class and change the casting. We don't need the casting anymore. And it says in the sample code, get the sample code from Canvas, create a new class that extends geometric object, but leave the class body blank. What syntax errors do you get, and how can you fix them? So we also went through that with the square class here as well. When I created the square class, it caused an error. And there are two ways to fix it, actually. One way is to implement the methods, which is the one that we went for. The other way is to make square abstract. So if you can have an abstract class that inherits from another abstract class. So now it doesn't need to implement draw anymore because it's abstract. It can't be instantiated. And then maybe if you subclass off of this one and it's not abstract, eventually you will have to implement the draw method if you want something that can be instantiated. But those are your two ways to solve the problem. Okay, I think that's it for this section. So abstract classes, abstract stuff is in italics in UML class diagrams. Abstract classes cannot be instantiated. You can't create objects out of them. And they can contain abstract methods, which are basically methods with no body that you then have to override at some point when you're creating a concrete class that inherits from the abstract class. Okay, let's take a look at the exercise. So I want you to do the exercise that follows on from vehicle, car, and truck. And like I said in the last video, I'd really like you guys to spend some time on this and try to get it right without looking at the sample solution. We will take it up and we'll go over all of this stuff in the live class again. But try it yourself. So if you haven't already, try these first two exercises, 1A and B. And then I would also like you to take a look at 2B. So the vehicle class is a lot like the geometric object class, right? So a vehicle from our point of view for this app has an engine with a horsepower, and it has a racing speed. But vehicle covers a lot of ground, right? Could be an airplane, a helicopter, a spaceship, a boat, a motorcycle, a truck, a car. It's too abstract to say what the racing speed actually is, or to say what the horsepower of it's going to be. So yeah. No, it's not. Sorry, it's not too. It's not too abstract to say what the horsepower is, but it's too abstract to say what the racing speed is going to be, because we need to know the type of the vehicle. So what I want you to do is I want you to now make vehicle abstract and figure out which of these methods does it make sense to be abstract, if any. So I want you to make those changes, and then I want you to add a motorcycle class with a speed equal to 1.5 times its horsepower, and adapt the main method so you can create motorcycles as well and make sure that it still works. Okay, so that's part B. There's some other good exercises in here as well, but we can leave those till the live class. I think 1A and B and 2B together may be enough work for you for now. Okay, so we'll take this up in the main class, and we have one more content video, and then the assignment. So we're going to talk about interfaces next, which is like abstract classes, but they're like even more abstract. So we'll talk about what those are and how they work and what they're for in the next video, and I'll try to remember to smile. All right.